Okay, in 8.3, we're going to talk about how to calculate a confidence interval for the mean when the standard deviation of the population is unknown. So when we don't know sigma, then we're going to substitute in S, which is the sample standard deviation. Remember, we learned how to calculate the sample standard deviation in Chapter 3. We didn't use this formula. We used the shortcut formula. But that's just showing that we learned how to do that back in Chapter 3. Now, the formula here we're going to use the standard error of the mean. So you notice that the only difference, instead of it being the standard deviation divided by the square root of n, we're not going to have the population, so we're going to use the sample standard deviation. So we're also going to use the t-distribution in place of the normal probability distribution. So if we replace sigma with S, we're going to use the t-distribution. So when the population standard deviation is unknown, we're not using Z, we're going to use T. Okay? So the t-distribution is a continuous probability distribution. So it continues just like the normal. It is bell-shaped and it is symmetrical. So that part is the same. The shape of the distribution is going to depend on what we call the degrees of freedom. Degrees of freedom is just n minus 1. The area under the curve is still going to equal 1. The t-distribution is going to be flatter and wider than the normal. The critical score for the t-distribution is going to be a little bit bigger than the critical z-score for the same confidence level. So the t-distribution is going to be a little bit bigger, and usually it's wider, the curve. Okay. And it's actually a family of distributions. And as the number of degrees of freedom increases, which is the sample size n minus 1, the shape is going to get closer to the normal. So the bigger the sample size is, which affects the degrees of freedom, the more it's going to be closer to the normal distribution. If you have more than 100 degrees of freedom, which means a sample size of more than 100, the t-distribution and the normal distribution, which is what we've been doing is the normal, they're going to look almost exactly the same. So if you look at this distribution and you see let's see, you see the normal, which is green, okay? If you look at the red, the degrees of freedom is 5, which means n minus 1. That's how we got the degrees of freedom. So the sample size here is 6. Oh, let me go back. And the sample size for the black line is 14. So as the sample size gets bigger for the t, it is getting closer to a normal distribution. And if it's, you can see that the t-distribution, it is bell-shaped and it's symmetric, but it has fatter tails than normal. They're wider, okay? So here's an example of a t-score and a z-score. For an 80% confidence level, which would mean alpha was 20.20, look at the degrees of freedom, okay? And look at Z. See how the degrees of freedom are bigger? But as T, okay, as the degrees of freedom increases, the sample size, see how it started out at 1.372? And then as we increase the sample size, it gets closer and closer to the z-score. So up in the sample size is going to make it more close to a normal distribution. Okay, here's the formula for the confidence interval. It's very similar. Everything's similar here, except instead of using Z, we're going to use that t-distribution. But the idea behind it is the same. The concept behind it. Like a 95% confidence interval, you're going to replace it with S, which is still a standard deviation. It's just a sample standard deviation because we don't have the population standard deviation. So you're still going to get your standard error of your mean. You're just using S. Okay, and then you're going to go to your table and find your confidence, your t value. You're going to find this table after the normal table, so table 5. And so you would look it up like we have been doing. Okay. And then you're going to calculate your confidence interval. You still have your margin of error. You're going to add and subtract it. Okay. So if you want to look up the t-score in Excel, we're going to talk about how to do that. If you want the margin of error in Excel, we're going to talk about how to do that. So that's kind of an overview of what this section is about. And after this video, we'll start working some problems.